Here's my tutoring on the limiting reactant dots. So first of all, you need a balanced equation, and you really, really, really need it. This says, though, that we need three of those and one of those to make two of those. Double checking that that's balanced, 6 and 2. Yeah, there we go. So it also tells you that the H's are the small ones and the N's are the big ones. It takes three of those for every one of those. So if you want to do it sort of the long way, you can do it this. It takes three for every one, and it takes three for every one. So how many times can you group 3 and 1? You can do it twice. Every time you run one of these, you get two of those. Every time you run one grouping of 3 and 1, you create two. How many times do you create two? You did it twice. So what's in the box after you get done? There are 4 NH3s, and there are 2 sets of H2 remaining. They are the excess. There are 2 H2s in excess. Let's do another one. I have a balanced reaction. Double checking 1C, 4, 4, 2. There we go. It takes one of these and two of those. Now the carbon is the stripy one, so these are the CH4s, and these are the O2s. It takes 1 and 2, so it takes 1 and 2, and it takes 1 and 2, and it takes 1 and 2. So I was able to make this grouping of 1 and 2 3 times. Notice that 2 O2s are left over. I don't care what order these are put in. You can put the extras first. I usually put the extras first. It doesn't really matter. For every time I run this, I get one of those, but I did it 3 times. Therefore, I get 3 CO2s. Every time I run this, I get 2 waters, but I did it 3 times, which means I get 6 waters. And I have 2 O2s remaining. And yes, I want everybody to put the excess here. I know it's there twice. Why is that there? Because it is remaining unused. It was the excess reactant. Now let's just do it by math. It's not a pictorial, it's just math. It's still 2 and 1 would create 2. I have 4 of each because remember what you have is not related to the recipe, to the balanced reaction. You can have whatever you have. You might have a million, but we're going to say we have 4 and 4 so that we have some numbers that are pretty easy to work with. It takes 2 and 1. Now, if I was going to use all 4, I would need double the amount of H2. Every one of these needs 2 of those. So if you use 1, you got to use 2. If you use 2, you got to use 4. If you use 3, you got to use 6. And nature will try to use up as much as possible. So we're going to try to push this to the limit, as far up, so to speak, as possible. So can I use all 4? No, because if I use 4, I got to have 8, and I don't have it. So when you get the wrong end of things, so to speak, turn it around and say it the other way. Can I use all 4? Well, I got to use even numbers because that's a 2. Okay, but 4 is an even number. So can I use 4? Well, probably. I mean, it's theoretically possible. So if I used 4, I would need to use how many? 2, because 2 only needs 1, and that is half as much. If you want to use 10, you got to use 5. I want to use all 4. Well, then you would need to use 2. Is that possible? Yes, I have to. In fact, I will have extra left over. So I will use all 4, and that will leave 0 of those. I will use 2 of those, and that will leave 2. How many times did I run this reaction? Well, instead of using 1, I used 2. So that's doubling the recipe. Instead of using 2, I used 4. That's doubling the recipe. So how many times did I run the recipe? Twice. So instead of getting 2, I get 4 because I ran the recipe twice. What's remaining? Remember this? There are 2 O2s remaining, and they are the excess. There's another way to think of this also. If 1 will get you 2, that's double, then 2 will get you, remember it's double, 4, same number. If 2 will get you 2, that's the same proportion. Then like 19 will get you 19, 142 will get you 142, and 4 will get you 4, same answer. Let's do another one. I have 6 and 10. So I'm going to show you what happens again when we do it sort of backwards by accident, because sometimes you just guess wrong. I want to use all 10. Well, okay, maybe, except how many H2s would you need? Remember, one will need 3. So if you want to use 3, you got to use 9. If you want to use 4, you got to use 12. You got to use triple. So if you want to use all 10, you got to use 30, and you're not even close. So that's not the way to look at it. Let's turn it around. I want to use all 3. Well, is 6 a multiple of 3? Yes. So can we stop dead on 6? We can. If I use all 6, how many will I need to use? Well, it's 1/3. Or you could say I'm doubling the recipe. If I double the recipe here, I got to double the recipe there. So I want to use all 6, but remember, we're doubling the recipe. So instead of using 1, we got to use 2. That leaves 0, and that leaves 8. So what's in the box? None of that. And 8 and 2s, and they are the excess. What about these? Remember I said I doubled the recipe? So if I double it, I will create double. I won't get 2, I'll get 4.